Welcome to Alchemical Science. I am Jordan Colin, an alchemist, an independent researcher, and a student of the inventor and vortex fusion specialist Malcolm Bendle. I've got a fairly exciting announcement and video for you today. I have received my Plasmoid Power kit set in the mail from Plasmoid Power in Thailand. So this is a Thunderstorm Generator kit set. It's very simple for experimenters, something to get started with, something that people can begin to study this technology and some of the phenomena that it deals with. So I'm going to go through each part of the kit set. We're going to show you what you get in the kit set. We're going to do a build and full installation on a Honda GX390 engine, which I'll show you in a minute. And then we're going to do some testing. So we'll do some emissions testing, see what we're getting out of the machine. Then I've got some, I guess, upgrades that we could talk about doing to the kit set, little easy things that you can do at home that from my experience building Thunderstorm generators with Malcolm Bendle, Michael Acris, some guys who really understand this technology, will help you produce better results, more consistent results, and maybe prolong the life of the parts of the Thunderstorm generator. But we're going to do a full build, see what we get out of this, just to spec out of the box. I already know a few people who've done the installation and they are getting great results out of their machine, so yeah. Okay, just a quick intermission here. I realize that there are a couple basic questions that people will have that we should quickly just cover now before getting into the build and the complete test work. I hope, of course, that you will watch the entire video through to the end and see the full summary of results obtained during my first tests. However, if you don't have the patience and you simply want to know now, does it work and can you buy it? I can answer those questions before we begin. And the answers are yes and yes. I was able to achieve excellent results during initial testing of the Plasmoid Power Thunderstorm generator install that I did here in Australia, and others already have achieved fantastic results as well, because the kit set is already available to purchase. So if you do wish to purchase the Plasmoid Power Thunderstorm Generator kit set, you can do so using the link that I've left in the description to Plasmoid Power's website. And I'm not a salesman for Plasmoid Power, nor am I earning any commission from your orders, so please don't reach out to me directly in regards to this. Go onto the website and get in touch with them directly. But stick around until the end of the video if you want to see the full results from my test work. For now, though, let's begin with the parts and the build process. So let's go through the parts of the kit set. That's actually step one on the installation procedure of the manual, is using the parts list provided in the appendix, confirm that all parts have been received in good order and condition. So we're going to do just that. All right, so I've got the appendix here, and I'll also attach this document to the description of the video so you can download it there and see it yourself. And you'll also, of course, get it with the Plasmoid Power kit set if you order that. So the parts list, we've got the air ionizer complete with bulb. So that would be here, and it says that the bulb is packed in the ionizer, and these all came bubble wrapped, but you know, I've just taken that off so that we can look right into it. Sorry, this flies around in Australia this time of year. So yeah, the bulb is indeed packed in there safely, and we can see the box of the bulb right there next to it. That's just a Reptile UVB 100, which you can get from pet stores if you happen to need a replacement later on. Then we have the bubbler, or the Plasmoid generator, which comes pre-made up there with the air stone in the bottom and the steel wool packed in. And these are obviously just simple off-the-shelf parts, so they've rigged up for the kit set. Yep, next will be the Thunderstorm generator itself, the Vajra. And I've had this inspected by Michael Acris, who is a certified welding inspector, and yeah, he has confirmed that there's no vacuum leaks, the welds are of decent quality, and overall this should be a good functioning unit when we run it. There is a little bit of flex in the system, even if we want to reach an ideal. So next we've got 3 semi-flexible spiral copper pipes with couplings pre-fitted, so that would be these 3 here, and these will be to go between the ionizer and the bubbler. Next up, we have this 1/2-inch flexible Teflon lined stainless steel tube here, which will go between the Vundra and the carburetor input. But once again, this is going to be something we're going to talk about changing later on, and we're going to do both of those tests. Then we have this aluminium plate, which is going to be used as a heat and electromagnetic shield between the Vundra and the Thunderstorm generator, because it does get very hot and we are putting it close to the engine. So this is something that's very highly recommended to do for safety. You know, when we're just playing around with experimenters kit set, obviously in an industrial setting, proper testing is done for this. But if you're playing around in your garage, you want to use this. And actually, Malcolm recommends using steel rather than aluminium. So if you have a bit of steel around, that would be recommended. And I'm going to show you that on the engine that we're doing. But this aluminium, absolutely better than nothing. Stick it on if you don't have anything else. Then we've got these threaded rods. And these are just to raise the fuel tank, because you want to, for experimental units, move that away from the Vundra as well. Again, just due to heat, plasmoids, it just makes sense. So this is another safety precaution that we should all follow. Next up, we have these 3 sets of fittings here. So the first one is the exhaust flange set for connections both to engine and to the muffler. So we've got the exhaust flange. I won't go through and point out all of these parts, because we'll go through as we unpack them and put them on the engine. I've already actually checked they're all there. But we have the exhaust flange, a pipe that's 1 inch and 20 centimeters long. And I'll be honest, I don't know what that's for yet, but I guess we're going to find out. A straight coupling, a flange 1 inch, bronze for the exhaust, the gasket muffler, some screws, and some tube high temperature sealant. Then we've got the carburetor flange set, and this is comprising of copper venturi, which this is really quite a decent looking copper venturi. We'll see how that goes. It's great to have these made of copper. This is really the ideal, so that's fantastic that this is a full copper venturi in this set. And then some couplings, a nipple, 2 gasket intakes, that'll be the gaskets on there, vacuum line, fuel line, throttle extension, throttle coupling. You'll see what all of this is for as I go through the build. And then in the last bag, this is the set fittings. So this has got a T for water filling, the gate valve. This is to adjust to be able to turn the ionizer on and off and allow air to flow through the bubbler. There's a nipple, 2 nipples, 2 clamp assemblies, so that's to fit the bubbler and the ionizer to the machine, and a heat shrink. We'll see what that's for as we go through the build. Alright, now this is the engine I'm going to be doing the installation on. This is a Honda GX390. I think it's a Gen Safe something or other. I'll put the actual model. This is something that's available, I think, from Sydney Tools in Australia. I'll correct that on the screen if I got it wrong. But yeah, this is the one I'm going to be doing the Plasmoid power kit set installation on. You can see that it's actually already had a kit set installed. This was actually the beta version of the Plasmoid power kit set. I'll cut in an image or a little clip of that here. But essentially, I've stripped this down. I've taken the old kit set off, so you can see these are going to be some steps that I'll be skipping in the instructions, but you can go back and watch my DIY build guide version 2, where I show all the parts of stripping down the engine, specifically on a Honda GX390, I believe. So just go back and watch that if you miss any of these steps. But what we've essentially done is just completely removed the muffler assembly from the exhaust. I've just left the gasket on here, and that has had the Vundra, the Thunderstorm generator, fit to it previously from the previous kit set, as I said. You can see that we grinded down the fins on the engine here, and that's just to be able to fit the Vundra closer for our experiments. And we're going to be doing that again later on, cutting down the exhaust output or the exhaust input on the Vundra, as I mentioned, to see what the thermal difference is and the results that we get there are. And then we've also already had a carburetor block, a spacer, installed here between the carburetor and the engine, which we're going to be installing the new one this time. So I've just left this kind of sitting loose here with the fuel tank disconnected. I've already got a heat shield installed on this one because we did it last time. This one's made of steel, which is actually a better heat shield than a better heat shield and electromagnetic shield than the aluminium. So I'm going to leave our one on here, and we may actually even use that little bit of aluminium to help raise the fuel tank up here. These are a little bit annoying because they're on an angle, but yeah, we can probably use that for that. Otherwise, this one's pretty much ready to go. We're just going to start installing the kit set on it and do some testing. All right, so before we go any further, I just need to mention, of course, that we are altering this generator, this engine, beyond the manufacturer's specifications. Obviously, we're voiding its warranty, and I take absolutely no liability for anything you do experimenting with this. You know, take my advice at your own will. I have no formal qualifications in working or with or altering engines in this way outside of working on thunderstorm generators. So, you know, this is up to you what you do here, and you take all responsibility for altering an engine outside of the manufacturer's specifications. The only other warning I really want to make is that this is not just an extension to the exhaust pipe adding the thunderstorm generator system. We are creating plasmoids. These are self-contained electromagnetic bundles, essentially, of energy, which flow through the system. And we've even showed in our overcharge experiments that they can leap out of the Vajra. So Malcolm Bendle has warned me, and I warn others, that this is not just an exhaust pipe. You just need to treat it with respect. This is a safe and self-contained system that's undergone extensive testing, but at the same time, understand that we are playing around with something that's a new phenomena to most people, and a lot of research has not been done in even many academic settings. So you're experimenting with something very new here. Treat it with respect. Understand that we take absolutely no liability, and Plasmoid Power claims in their kit set that there is no warranty or liability taken by them for any mishaps that could go, you know, wrong here, whether you damage your engine or, you know, damage yourself. Please just take heed of the warning and be safe. Otherwise, you should be fine. This is very easy. I've known a number of independent replicators who put it together, even this specific kit set by now. I'm a little late to the ball here doing my videos, so have fun, be safe. You should have no problems in your build. All right, so continuing on with the installation procedure, there's a few things that I've done with the engine. You can see I've now raised the fuel tank. So they say here's step 2 before any modifications are made. Confirm that the portable electricity generator operates properly. We've done that with this unit. It's been tested before I've started this. Then empty the fuel and store in a safe place. Fuel tank was empty, and I've checked that. Evaluate the generator and confirm that after removing the muffler, there will be sufficient space to fit the Vortex thunderstorm generator within the frame of the generator. The fuel tank will be raised. It may be necessary to remove one of the wheels to allow this, as the Vortex entries and exits may conflict. So we have raised the fuel tank. I've actually used the aluminium plate, which they gave, because I've already got our steel heat and electromagnetic shield here on this engine. So that's been raised well out of where the Vajra is, about the same height as the threaded rod, which they provide in the kit set to raise it. And you'll see in the instruction manual how that happens, and I can cut in an image of a generator in which they've done it in the standard way. This one just has a little bit of a different fuel tank, which is why I've raised it in this way. Next up, number 5, remove the muffler, exposing the exhaust port of the engine, and check that the flange provided is suitable. Retain the gasket for later use, and block the port with a cloth to prevent ingress of contaminants. So I've removed the entire muffler assembly here. You can see it's just down to right up against the engine. You can look in there and see combustion happening. And I've also checked the flange, and it actually doesn't fit properly. I'll So it's actually slightly too big for this engine, but what I'm going to do is just drill out these holes a little closer to it. Okay, so I've just roughly drilled out that hole a little more, and it fits just fine there now, so we can move on to the next step. All right, I've hit a little bit of a roadblock, unfortunately, so this is going to need to go back to Acris so they can make up a new exhaust flange, because unfortunately, even with the altered holes, I'm not going to be able to fit the nut on the other side, and I really don't want to shave this down. That will really start to compromise the integrity of it, because this gets very, very hot. So unfortunately, this one isn't going to fit a GX390. Just thought I would show this part of the process. So if you're fitting a different engine, then I'm not exactly sure what they recommend here. I'll have to cut that into the video once I find out. Then you may need to make a custom exhaust flange, which is, you know, this is not a terrible job exactly. You can certainly find any local manufacturer or welder will be able to do it for you if you can't do it yourself, but something to consider. So we will continue with the build down at Acris once I've got them to make up another exhaust flange, and we'll go from there and do the testing. All right, so now we have our flange made up by the guys that's going to fit the GX390. We've got the Vajra here, so we're going to continue with the build and see how the Vajra is going to fit, and then we're going to fit on the bubbler and the ionizer. So you can see here, that's the wrong way around because the pipes will be going back into the engine, so be careful about which side you put it on. There we go, it'll go on like that. So I am going to use some of this exhaust system sealant that was included in the kit set. I'm just going to put a spread here on the thread, stick my gasket on, and then we're going to attach the Vajra to the engine, and then we can fit the rest of the system from there. Okay, so I've just used that exhaust cement to stick the flange onto the Vajra, and now we're going to put the Vajra onto the engine so we can size up the rest of the system. So there is, of course, the original gasket still here between the engine and the flange. And there's our Vajra installed nicely on the engine. You can see it comes out fairly far from the exhaust, and that's something we're going to test with thermal testing to see if we are losing any efficiency. Okay, so now just finishing off preparing the engine, I'm going to mount this bar just across the frame, which is what we're going to attach the clamps for the bubbler and the ionizer. So I'll just whack this in now. Okay, that's on. So next up, we'll be fitting these clamps. So as I say, we're trying to line the bubbler up, you know, just as much as possible with the Vajra here. Obviously, we're going to bend the pipe a little bit as needed, so it doesn't have to be exact, but we're going to put it as far over as this frame will allow. So I'll just mark out and drill a couple of holes here. All right, so that is the first clamp solidly on there that we'll put our bubbler in. The next up, just taking the ionizer, and to make sure we size this properly, I've got the tank valve down the bottom, and they also include a filling valve in the Plasmoid power kit set, which goes above the a filling T above the valve, which is not really necessary because you can fill it from the ionizer, but it's on here, so I'm going to install it with the kit set. So just for sizing, I've got the T for the filling, the valve, and then this compression fitting at the end to go on the copper pipe. So we'll just thread that onto the bottom of the ionizer. Obviously, I'm going to have to do all of these up with thread seal tape, as vacuum is very important in the system, but for now we just want to size it up so we can see that it fits. Right, so here's our ionizer made up, and it's got the filling valve and the tank valve on the bottom. So we're just going to see how this fits with the bubbler. All right. I did have to move my bubbler down just slightly so that we could make this all work easily. So the ionizer is going to go around about here. So let's put that in. I can pretty much match this up with the hole that's already existing here. So this is really easy for me. I will just mark out the other hole with my extra hand that I don't have. All right, that's the holes drilled. So we will put this next one on. All right, so that is our bubbler and our ionizer fitted to the unit. What we're going to do next is just seal up all of these fittings with Teflon tape, aside from the compression fittings here, and we'll just go A to B, A to B, and then A to B over to the Vajra, and then we'll do the carburetor assembly, and that's all we've got to go. See if we can fit this on there. So just a quick note that these are compression fittings, and they've got these little olives in there that'll crush down, so we don't need to put thread seal on here. It can actually disrupt the seal. So you just got to be careful not to over tighten these, but they do need to be fairly tight to crush that in there. We'll check the vacuums on this when we test it soon. And that's the bubbler and the ionizer complete and connected and hopefully sealed. Okay, now that the bubbler and the ionizer are connected, we're going to connect the bubbler to the cold input of the Vajra. So I'm just going to use Teflon on the Vajra as well to create the seal. It's rated up to about 260 degrees, and although the Vajra gets very hot, the cold input and output, they shouldn't reach those kind of temperatures. So I'm just going to use Teflon on here and put the fittings on, and then we'll fit our pipe in. All right, so I'm going to fit this pipe in now between the Vajra and the ionizer. Sorry, the bubbler. And actually, sorry, I didn't mention here, but I just got the guys to silver solder this connection in the middle here. They just say use some sealant, but I have access to a workshop right now, so I got it done properly. That's going to create a good vacuum proof seal there. Otherwise, honestly, I'd consider just getting one length of copper pipe. Not that hard to find. Just avoiding vacuum leaks is one of the hardest things to do in the build, so ideally you don't really want these weak points. All right, and that's our pipe between the bubbler and the input of the Vajra, all sealed up. Next, we are going to put the carburetor spacer in, and then we're going to make the connection between the Vajra and the carburetor spacer, and then we're nearly complete. All right, so I'm just quickly checking out the carburetor fitting, and it looks like it's going to be a little bit too wide. It's going to hit up against our engine, so rather than modifying the engine in any way, I've just marked out to cut off the back of the flange, which won't affect the connection at all. So we're going to do that now, and then we'll be able to connect the carburetor block. All right, so you can see I've removed the entire carburetor assembly already. That's just unscrewing the little bolts that go in there that the whole carburetor assembly sits on. So what we are going to do is first install this one here. which I've cut down, so I'll grab some bolts that fit. So with the kit set, we don't actually need to use the rods that were pre-supplied because they've made this two-part spacer here, so that we're just going to use the bolts straight in here to fit it on, and then we'll fit the other side, the carburetor, back on using separate bolts. All right, so we're going to fit the carburetor block on here now, and remember that they've supplied gaskets. You need to put gaskets in between everything, so we're going to do that, of course. All right, so you can see I've tightened on the carby block here, so now we can put the rest of the carburetor assembly back on the end. All right, so that's the carburetor here. Just going to see how that fits up. Make sure our holes all still line up, which they absolutely do. So I'll find some more bolts and we'll put this on. We have fit this up and tightened it up, and we're just going to put the carburetor back on the end now. I have just cut these little bits of M6 rod just so we can fit it straight through there. Put bolts on both sides, and should be tight. Okay, so that is fairly tight. We'll probably give it another tighten after we've given it a run. It's always good to do it a second time. Be sure not to over tighten, but it does need to be pretty tight on there. We don't want vacuum leaks in this area at all. All right, so I think we've only got one last piece to do. That's what it looks like. We've just got to connect our Vajra cold output into the carburetor input, so we'll do that now. Last piece. All right, now the last piece to connect is this braided hose. Like I say, not a huge fan of this, but it is flexible, easy to install. So we are going to test, do some thermal analysis, and then I'm probably going to replace this with a copper pipe, and we'll try again. And also remember, there is this heat shrink sleeve, which just goes over the end here, just to help isolate things from the engine. I haven't done this before, to be honest, but it doesn't sound like a bad idea, so we're going to follow the instructions and do that. All right. Yeah, I think we'll do that way for the braided hose. Okay, and that's the build basically complete. We've just got to reconnect the fuel line here. We'll see if the kit's going to work out for that. They've given me a longer fuel line, and yeah, I think that's just going to reach, so I'll replace that now. All right, and that is the fuel line installed. I've just got to bolt the fuel tank back down. All right, that is the build complete as far as I can see. We're going to do some testing now, make sure there's no vacuum leaks. So you can see the Vajra installed on the front there, the carburetor block, and the bubbler and ionizer on the side. I think this is not an Australian plug, so I might just switch it out with another lid that I have, and we can get this running. So light is out of the ionizer and fitted into the lid, and that's going back in here. We won't put that on too tightly right now because we're still going to put the water in. Okay, so I'm going to start off with putting about 200 mils in the bubbler, and then we're just going to run the unit, and as we see how it's functioning, I'll add a little bit more in. Where we at? About 350. Okay, so that's about 200 mils in there. We may need a little bit more. You've pretty much just got to have it probably about there, over the air stone, but not too high because we don't want it jumping all over the place. We just need enough to form that milky froth, ideally, to create the plasmoids. Okay, so there's just one more part to the build, which is to just add this little governor extension. So the governor is this little straight piece that goes between here and here. It's kind of like the throttle on a car. It controls the revs of the engine. But because we've elongated the carburetor out, Plasmoid Power have included this little extension kit. So we can just make it a little bit longer and it should function correctly still, we hope. This can be a little bit fiddly. You might have to do a little bit of tuning here. All right, so we've added that governor extension in there, and we're about to run the engine and give it a shot. So we've got 2000 watts of load plugged in, which is what we usually run on this generator just for a standard quick test. But main things we're going to be looking for is, have we established vacuum in the system? If so, then we're going to do some emissions testing, and then if that works out, we're going to do thermal analysis with the thermal imaging camera at the entire system. And we're particularly looking at this point here because we're going to shorten that afterwards, and then we're going to make a comparison to see if we're losing heat and efficiency through having the exhaust output a little too far out, because Malcolm says you lose about 100 degrees per inch here. And then we'll also consider changing this copper pipe as well. But for now, running the test as is on the engine built spec according to Plasmoid Power's build guide. All right, so we're going to start the system choke off and the valve completely closed. And then we'll slowly open the valve from here. And actually, I can already see I've got a very small water leak, so we're going to try and tighten that up. So I'm just going to really quickly check these compression seals, because as I say, they do need to be fairly tight, otherwise we have that happening. One last quick thing to note is just double check that there is absolutely nothing touching or grounding out on the frame. Very important to do before you run it. And we're okay. On, fuel on, choke off, valve completely closed to start this time, and let's give it a shot.
All right, so I've just done some basic tuning with the machine. We can see that the bubbler is functioning, and I'll get a slow-mo footage with how that's functioning. We have vacuum, so we're going to do some emissions testing. There is our Gain certified emissions tester, 5-gas analyzer, so we can see primarily ambient, who hasn't got the probe in at the moment, and Ben's going to now put the probe in. First run. We're going to let it run up, charge the system a little, and do some more testing.
All right, I've stopped the test there. We are getting some good initial results. Below 2% CO2, still around 100 parts per million hydrocarbons. That's not fantastic, but we do need to charge up the system. Ultimately, what we are going to do is empty a little bit of water out of the bubbler because there seems to be a little bit too much in there, and that can sometimes cause these results, but we're going to try that first. We are going to check for vacuum leaks next, and also I can remember last time this little bit on the side of the bubbler here, just this is, you know, like a water filtration fitting, that was leaking, so we're going to take that out and seal up that hole there as well. Just make sure that there's no vacuum leaks, but we are getting vacuum in the bubbler. It could be a little bit better, but it's honestly not bad. I think we've got a working system here that just needs a little bit of tuning. Okay, so I have gone around and tried to seal up some of the potential vacuum leaks that we had. Particularly, this was a weak spot here on the bubbler. They replaced this relief valve just with a screw, so we've sealed that up with epoxy to make sure. I'm about to run it again. We'll run it with no load first, and then we'll add the load in, and we'll test both of those. And then afterwards, I will do thermal analysis again, and hopefully we have a good working machine this morning.
So we're just waiting a minute for it to stabilize. All right, so much better results this time. We're getting 19.3% O2, 0.12% CO, 1.3% CO2, and 6 parts per million hydrocarbons. It's working. If we charge that up, that'll be perfect numbers soon. So I'm going to go and plug the load in, and we'll see what we get. Okay, I've added 2,000 watts of load. That's 4 500 watt lights, and now we're going to test again. So that's 20.4% O2, 0.27% CO, 0.51% CO2, 7 parts per million hydrocarbons. We have a functioning unit, and that's pretty good results. Nice. Next up, I'm going to do thermal analysis again on the entire system. I'll be recording this on the phone, and we'll put that in as well.
All right, so that was our second test after filming a couple vacuum leaks this morning after the first test to medium success yesterday. And the machine is producing really decent results. We're getting pretty close to 20% oxygen and very, very low CO, about 0.05% I think it was, and fairly low CO2 as well, where it was under 1% for both tests, or around 1% for the test with load. So that's going to improve as we run up and charge the system a little bit further. And yeah, I think I'll probably do a fuel consumption test on this now. as is, and then we're going to shorten the flange on the Vajra. We're going to try again. Alright, so I ended up doing rather a lot of testing on this unit over the holidays while everybody normal was having a break, and this took me over a week, and I didn't film all of it, as it's simply too much footage to make an interesting video, so I'm going to just summarize the important data that I gained and the things that I learned from testing and compare different configurations of the machine that I tested. First of all, and I think anyone doing their own build and testing will find this very useful, I documented this simple startup and tuning procedure. So following these steps, you can optimize your results and get the cleanest burn possible from your setup. Anyone who has tuned a regular engine before will find these steps familiar. The Thunderstorm generator only really adds one variable. Instead of controlling airflow only through the carburetor choke valve, we now need to balance airflow from two sources, the carby as usual, but now also from the bubbler valve. Just as in the case of tuning a normal engine, tuning is simply about balancing the air-to-fuel ratio to get the cleanest burn. It's just that with the Thunderstorm generator, the cleanest burn actually involves completely zeroing out the CO and HC and significantly lowering CO2, which is obviously not possible in a normal unaltered engine. So here is the basic tuning procedure, step by step. Start the engine as normal. The choke should be completely closed to start if the engine is not already warm. If the generator is under no load, the bubbler valve should be closed or mostly closed when the engine is started, and if the generator is under load, then the bubbler valve can be completely open when starting the engine to save opening it later. Once the engine is running, open the choke valve slightly to around 90 to 95% closed still. If the bubbler valve is not already open, then slowly open it until you hear the engine RPM increase. If the engine is chugging, then adjust the idle screw until it's a fraction of a millimeter from the governor and the RPM stabilizes. Because the RPM generally increase when you hit the airflow vacuum sweet spot with the bubbler valve, then you may also need to tune the idle screw or the RPM down a little to bring the engine back close to normal generator operation. So that's around 3000 RPM. That equals 50 Hertz in Australia, or 3600 RPM is 60 Hertz in, I believe, the US and other places. If the engine is popping or still chugging, then it's running lean and you need to reduce the airflow a bit. So do this first through the choke valve without closing it more than 95%. You still want a smaller amount of airflow through the choke, and this helps establish vacuum through the bubbler and improves overall emissions readings. Allow the gas analysis readings to stabilize. If CO and HC still remain, then this signals incomplete combustion of the fuel. The engine's running rich. Incrementally increase the airflow with the bubbler valve first, and if CO and HC still remain when the bubbler valve is completely open, then begin to open the choke valve until CO and HC are completely zeroed out. Small amounts of HC can remain in less optimal systems, about 1 to 30 parts per million, but HC readings much higher than this, or CO readings higher than 0, signal that the system requires further tuning. Some CO2 may remain in less optimal systems, but generally only 1 to absolute maximum 3.5% under load. This is a significant improvement over baseline tests and standard CO2 emissions at stoichiometric ratio. However, if more than 3.5 CO2 is observed during testing, or if CO and HC can't be zeroed out or got close to zero, then further tuning or optimization of the system should be considered. Okay, so those are the steps that I followed during all of my future tests to standardize the engine's operating conditions and achieve optimal results possible in the current configuration. Now let's take a look at the data. Let's start with the fuel efficiency test rather than the emissions for a change, because I was able to make some adjustments to the system which achieved some quite impressive and consistent results by the end, by normal scientific standards. So we can see the data recorded from my 100 ml fuel consumption tests here on this unit in the table. And these are only the tests that I did under 2000 watts load. I did also perform them without load as well, simply out of curiosity and to compare. But obviously the tests under load are the practical results that we're most interested in. But for reference, if you're interested, the tests without load showed a very similar increase in runtime to the tests with load this round. Oh, and the fuel used for all of these tests was just unleaded 91 petrol, or gasoline for you folk in the United States. So we can see that the initial fuel consumption test I did was a little underwhelming, pretty much the same as the baseline engine's performance. It increased by less than 1%. But making a few changes to the configuration and spending a bit more time tuning the unit gained some significant further increases, as you can see, and by the end of the test work I was consistently seeing the 30+% increase under load as shown in the final tests I recorded here. And these are great results. 30% increase in runtime on the same amount of fuel is no small saving. Huge increases in efficiency. I have seen even better results on other systems in the past, but there is nothing wrong with a healthy 30% increase in runtime at all. The thing works, and by following these steps, in particular, I found reducing the 3/4 Venturi to the 1/2 inch for this size of engine really helped. There is no reason that these results, or even better results, can't be repeated by anyone who attempts their own build. This is one test that is quite easy and affordable to do at home. Now let's take a look at the emissions results though. In the first column, after the baseline results, you will see my own best recorded results. Now I'm being quite conservative here. I did actually achieve results better than this during my tests, as you will have seen in the video footage if you looked carefully. But after many hours of testing, I want to be honest for now and show you an average of the best results that I was able to achieve consistently over long periods of time and multiple tests, because this is a really impressive result, all things considered there. The Honda GX390 is also a larger engine than the other installations here that I'm comparing to, and it's harder to achieve optimal results from my experience with it. But this is a really good thing, and why it's good for using for test work. Sometimes on the cheaper knockoff Honda engines or on the smaller engines, results can be so perfect that it's difficult to actually get any real feedback on what you're doing. The tolerances are so wide on some of these smaller or the cheaper generator systems that you can get pretty decent results no matter what. So this initial result that I've recorded from my testing on the GX390, it gives us room to play with further optimization. And after some recent talks with the inventor, Malcolm Bendle, I do have a few more tricks up my sleeve to try and improve these results even further in my future test work. However, outshining me for now, Kevin Baker of Plasmoid Power, he just achieved these new results and sent them to me just today as I am finishing off this video. And so I've included those here. These are really excellent results. He sent me some video footage of that. And I also have shown the results we obtained from David Evans' independent replication back in 2025 last year. So David was one of the first replicators to purchase the Plasmoid Power kit set and conduct his own build in Australia. He had one quite a few months before I did, and he was also able to get some consistently excellent results from his machine. So the new kit set has actually been on the market for a few months now, so there's quite a number of folk out there who've already completed their builds, or they're just about to start. A few of them have posted videos online if you go and take a look. So hopefully you'll all find this video of some assistance, and I encourage you to record your own footage of your build and your tests and share it as well. So in conclusion, does the Thunderstorm Generator Plasmoid Power kit set do what it says on the label? Yeah, it absolutely does. If you want to get started with experimenting with the Thunderstorm generator, whether you are a home replicator or a scientist, then this is a great way to do it with minimal effort. All the parts of the kit are there, and it really doesn't take much to retrofit it to the engine and get it running. The whole build can be completed in a day or two with the kit set. So if you want to go and find one of those yourself and do your own build, then you can follow the link in the description and reach out to Plasmoid Power there. As I said at the beginning of the video, don't reach out directly to me. I'm not a salesman here. I'm not earning a commission from your order. I'm just doing this in an educational and scientific capacity, so please reach out to them directly if you're interested in that. But we will likely be doing much more testing on this particular unit in the future, and if you're in Australia, it's likely that you'll see it used at some more public demos later this year. So best of luck with your builds. I hope you found this video helpful. Thanks again to Plasmoid Power for providing me with a demo unit to trial out of the box, and thanks also to Malcolm and Strike Foundation, Michael and Acris Industries, and Ben Miller for all assisting me with advice or practical help for parts of the build and the testing process. I'm Jordan Colin, and this is Alchemical Science. Stay tuned, and I'll see you next time.